Probability and probability distribution. Probability theory deals with situations in which there is an element of randomness or chance. The mathematical theory of probability arose in consideration of games of chance but is now widely used in far more practical and applied situations. A random phenomenon is a situation in which we know what outcomes could happen, but we do not know which particular outcome will happen. For any random phenomenon, each attempt or trial generates an outcome. Something happens on each trial and we call whatever happens to the outcome. Experiment is a process of observation that leads to a single outcome that cannot be predicted with certainty. Probability of a single event. If we roll a 6-sided dice, there are 6 possible outcomes and each of these outcomes is equally likely. A 6 is as likely to come up as a 3, and likewise for the other 4 sides of the dice. What then is the probability that a 1 will come up? Since there are 6 possible outcomes, the probability is 1 by 6. What is the probability that either a 1 or a 6 will come up? The 2 outcomes about which we are concerned are called favorable outcomes. Given that all outcomes are equally likely, we can compute the probability of a 1 or a 6 using the formula probability. Probability is the branch of mathematics that studies the possible outcomes of given events together with the outcomes' relative likelihoods and distributions. In common usage, the word probability is used to mean the chance that a particular event or a set of events will occur expressed on a linear scale from 0 impossibility to 1 certainty, also expressed as a percentage between 0% and 100%. The analysis of events governed by probability is called statistics. There are several competing interpretations of the actual meaning of probabilities. Frequentists view probability simply as a measure of the frequency of outcomes, while Bayesians treat probability more subjectively as a statistical procedure that endeavors to estimate parameters of an underlying distribution based on the observed distribution. A properly normalized function that assigns a probability density to each possible outcome within some interval is called a probability density function or probability distribution function, and its cumulative value is called a distribution function. A variate is defined as the set of all random variables that obey a given probabilistic law. It is common practice to denote a variate with a capital letter. The set of all values that x can take is then called the range, denoted Rx. Specific elements in the range of x are called quantizers and denoted x, and the probability that a variate x assumes the element x is denoted P. X is equal to x. Probabilities are defined to obey certain assumptions called the probability axioms. Let a sample space contain the union U of all possible events EI, so let E and F denote subsets of S. Further, let F is equal to not F be the complement of F, so that F union F is equal to S. Then the set E can be written as probability distribution. Probability distributions are a fundamental concept in statistics. They are used both on a theoretical level and a practical level. Some practical uses of probability distributions are to calculate confidence intervals for parameters and to calculate critical regions for hypothesis tests. For univariate data, it is often useful to determine a reasonable distributional model for the data. Statistical intervals and hypothesis tests are often based on specific distributional assumptions. Before computing an interval or test based on a distributional assumption, we need to verify that the assumption is justified for the given data set. The distribution does not need to be the best fitting distribution for the data, but an adequate enough model so that the statistical technique yields valid conclusions. Simulation studies with random numbers generated from using a specific probability distribution are often needed. A probability distribution is a table or an equation that links each outcome of a statistical experiment with its probability of occurrence. Cumulative probability distributions. A cumulative probability refers to the probability that the value of a random variable falls within a specified range. Let us return to the coin flip experiment. If we flip a coin 2 times, we might ask, what is the probability that the coin flips would result in 1 or fewer heads? The answer would be a cumulative probability. It would be the probability that the coin flip experiment results in 0 heads plus the probability that the experiment results in 1 head. P x is less than 1 is equal to P x is equal to 0 plus P x is equal to 1 is equal to 0.25 plus 0.50 is equal to 0.75. Like a probability distribution, a cumulative probability distribution can be represented by a table or an equation. The cumulative probability refers to the probability that the random variable x is less than or equal to x as follows. Uniform distribution sample. The simplest probability distribution occurs when all of the values of a random variable occur with equal probability. This probability distribution is called the uniform distribution. Uniform distribution. Suppose the random variable x can assume k different values. Suppose also that the p x is equal to xk is constant. Then p x is equal to xk is equal to 1 by k. Simple and compound events. Suppose we randomly select 2 people from the members of a club. Look at whether the person selected each time is a man or a woman. Write all the outcomes for this experiment. Probability is the mathematical framework for describing, modeling uncertainty. It is a numerical measure of the likelihood that a specific event will occur. 2 or more outcomes or events that have the same probability of occurrence are said to be equally likely outcomes or events. Probability is denoted by P. PE denotes the probability of the event E. What is the probability of getting a spade when a card is drawn from a well-shuffled deck? Let E be the spades. Then we denote the possibility of getting a spade by PE or simply P spade. Calculating probabilities. Classical approach. Assumes all outcomes of the experiment are equally likely. Let's look into an example of a couple with 3 children and they will at least have 2 boys. Assume that boys and girls are equally likely and that the gender of any child is not influenced by the gender of any other child. The outcomes can be shown in this video. Relative frequency approach. Probability of E may be interpreted as the relative frequency of the E over a long series of experiments. Law of large numbers. If an experiment is repeated again and again, the probability of an event obtained from the relative frequency approaches the actual or theoretical probability. Probabilities must be between 0 and 1 inclusive. A probability of 0 indicates impossibility. A probability of 1 indicates certainty. Conditional probability. The conditional probability of an event B is the probability that the event will occur given the knowledge that an event A has already occurred. This probability is written P B by A, notation for the probability of B given A. In the case where events A and B are independent, where event A has no effect on the probability of event B, the conditional probability of event B given event A is simply the probability of event B, that is PB. Let's now look into this video to understand the concept clearly. Bayes' theorem. Bayes' theorem describes the relationship that exists within an array of simple and conditional probabilities. In order to explain the Bayes formula, let's see another video. Summary. Probability is the branch of mathematics that studies the possible outcomes of given events together with the outcomes' relative likelihoods and distributions. Statistical intervals and hypothesis tests are often based on specific distributional assumptions. Before computing an interval or test based on a distributional assumption, we need to verify that the assumption is justified for the given data set. A cumulative probability refers to the probability that the value of a random variable falls within a specified range. The conditional probability of an event B is the probability that the event will occur given the knowledge that an event A has already occurred. Bayes' theorem describes the relationships that exist within an array of simple and conditional probabilities.